All right, this is lesson 3.3 on graphing and writing horizontal and vertical lines. So our bell work, let's go over that. This is a different bell work. So for the first line, it was negative 2x plus y equals negative 3. So you had to get it into slope-intercept form by adding the 2x over. So it'd be y equals 2x minus 3. You don't have to divide anything because y doesn't have a coefficient. And then to graph it, you would plot the y-intercept at negative 3 and then use the slope of 2 to get additional points. So you would go up 2 and over 1, up 2 over 1, up 2 over 1, and I hope that when you graphed it, you plotted as many points that would fit on the line, not just 2 points. That makes our line more accurate. And then you can also go in reverse to plot points to the left of the y-axis by going down 2 and left 1. Down 2 and left 1 is the same as up 2 and right 1. I think some of you guys were like debating about that yesterday. So then you can draw your line. Not sure where this other line came from. So that's the first one. And then the second line has an equation of, hang on a second, 2x minus 5y equals 10. So for this one, you have to subtract the 2x over. So you would get negative 5y equals negative 2x plus 10. And then you have to divide everything by negative 5. Then you would get y equals positive 2/5 x minus 2. So these are skills we learned last unit to convert into slope-intercept form, and skills we'll continue to work on this unit because we need them all throughout the year. Okay, so this is our equation that we're going to graph. It has a y-intercept of negative 2 and a slope of 2/5. So you're going to go up 2 over 5. You can also go in reverse, down 2, left 5. Then you can plot or graph your line, connect your points. So for this one, you should have 3 points on your line. One in the middle, one on the right, and one on the left. Okay. Any questions? How did you do? You get the first time? Maybe? Okay. We'll continue. So in chapter 3, it's all about graphing linear equations. So we're skipping 3.1 and 3.2 because we covered them yesterday in our IXL. So it's just plotting points on the coordinate plane and then graphing linear equations. And those are things that we just review because you learned them last year. Today we're going to learn about vertical and horizontal lines, and then next week we're going to continue 3.3, which is graphing using intercepts. And then we'll learn how to find the slope and rate of change of a line, graph in slope-intercept form, like what we did in our bell work, but also word problems. We do 3.6, which is direct variation, which is usually a pretty easy lesson. And then for 3.7, it's graphing linear functions, specifically like word problems. All right, so in these notes, it calls vertical and horizontal lines strange lines because they're just different from a regular slanted line that we're used to. It says, although they don't fit the classic linear model, it's important to understand how do we write equations of horizontal and vertical lines. So here we're given a horizontal line and then a vertical line. The first thing they ask us to do is write down 2 coordinate points. So we'll write down the coordinate points that are shown. So the point on the left here is at 1, 2, 3, negative 3, 4. And then the point on the right is at 1, 2, 3, 4, 5, comma 4. What do those points have in common? Trent?
They're on the same y.
Yes, they both have the same y coordinate. So the y coordinate is the same. So in order to write an equation of a horizontal and vertical line, they're different from regular slope-intercept form. Since all of the y's are the same, we would just write it as y equals whatever the y values are. So in this case, it would be 4. So the equation of the line is just y equals 4. That's its equation. That's the equation of a horizontal line. And it's also, notice that the line crosses through the y-axis at 4. So that's another way to tell what the equation is whatever it crosses through. So if it crosses through x, it's x equals. If it crosses through y, it's y equals. For our vertical line, the two coordinates are 2, -1 for the bottom one. And then the one above it is at 2, 4. So here the thing they share is the x coordinate. And notice the line crosses through the x-axis at 2. That means the equation is x equals 2. So horizontal lines have the form y equals a number, and it's whatever number it goes through on the y-axis. And vertical lines have the equation of x equals a number, and that number is whatever it crosses through on the x-axis. Okay, so horizontal and vertical lines are so simple that sometimes we forget about them because of that, because they're so simple, and we expect them to have to be like mx plus b, and they do not. So they are different than slanted lines. They have different types of equations. It's just y equals a number, x equals a number. Okay, so that's what we're going to practice today. So which of the following represents a vertical line that passes through the point 5, -3? Which one is vertical? Owen? Oh, sorry. Evans. Yes. Wait, yeah, number 2. Sorry, Owen sits there, and your last name is, oh, how do you say your last name? Oh. Okay. So yeah, it's this one. So this one's vertical. We could also write number 1, which is horizontal. And then number 3 would be slanted down because the slope is negative. So number 2 is the one that answers the question, but I'm also going to classify the other ones. And then number 4 is slanted up because the slope is positive. So this has a negative slope, this has a positive slope. So the next page, we're going to practice writing the equations given the graph. So for A, it crosses through the x-axis at 1, 2, 3. So the equation would be x equals 3. For B, it crosses through the x-axis at 1, 2, 3, -4. So the equation would be x equals -4. For C, the line crosses through the y-axis at -1. So the equation would be y equals -1. See how easy these are? So what's the equation for part D? Des? Yes. How about for E? Lane?
Y equals 4.
Mm-hmm. And then for F? Courtney? Yep. So simple. For G, the equation of a vertical line passing through the point -4, 5. What would this one be? Trent?
X equals -4.
Yes. Vertical means it's x equals whatever the x value is. For B, Amelia? Yep. All right, now we're going to practice graphing them. So the first one is slanted. It says label each with the equation. Also, we're going to find the area of the region, which will be a triangle enclosed by the lines. So the first one is slanted. It has a slope and a y-intercept. So we put a point at the y-intercept at -4. And the slope is 2. So we could go up 2 over 1, just like we did in the bell work, up 2 over 1 and keep putting points. And then also down to left 1. In order to label a line that you graph, you just write down the equation next to it. For x equals -1, to graph a vertical equation, you would put a point at whatever the x value is. So you would put a point at x equals -1 on the x-axis. And then you would put a point anywhere above or below it. Doesn't matter where, just pick a point. And then that's what you can use to connect the lines. Because vertical lines, x equals is vertical and you want it to be going up and down. Then you would label it as x equals -1. And then for y equals 2, you would put a point at y equals 2 on the y-axis. And then put another point anywhere to the right or left of it. It doesn't matter where. Just pick a point. And then draw, oh, you're using your straight edge to draw the lines. I hope I made that clear. Does everybody have a straight edge at their desk?
Is that the ruler?
That's the ruler, yeah.
It's the ruler.
Yeah, we don't actually use the rulers to measure things. We use them as straight edges. Okay, so you should never, ever freehand a line when you're graphing it. Alrighty, next we're going to shade the region that's bound by these 3 lines. It should be a triangle. Wait, don't flip your page over yet. Did you find the area? And then we're going to find the area. So area of a triangle is 1/2 base times height. So what's the base and the height? Abby? So 4 is the base. Put that in for B. And then what's the height? Count again. Make sure you're counting all the way to the line, not just the x-axis. Yes. And then we can multiply. So 1/2 times 4 is 2. 2 times 8 is 16. And then since you don't have a unit, you would just put unit squared. Okay, so that would be the area. Now you can flip your page. So the next part, you're going to do the first part by yourself. For part B, I wrote an equation that I want you to graph since the line is like repeated from the last page. So it says to graph the equation y equals -4. And then for part C, it says x equals -2. So ignore the lines that are there, and I want you to graph the equations that I wrote. I'll give you a few minutes to work through that. You can keep going through the page if you're done with the graphs. I'll give you another like 30 seconds before I do sticks. Yeah, it'll go through the y-axis. You just want to figure out which axis is it going to go through. So it's perpendicular to the x-axis. It's going to be going like this. It's going to go through the x-axis. So it'll be x equals. Okay, let's do sticks. Number 1A. Savvy? Is it 1 or -1? It's -1. Yeah, -1. For B, I'll just do this one. 1, 2, 3, 4. Oh, sorry. No, not that one. Y is 4. 1, 2, 3, 4. -4. So your line should be going like that. And then for part C, x equals -2. We'll go through -2 on the x-axis and go up and down like that. Okay, you see the y here? This is your y-axis. So to the left would be -1.
Yeah, so it's a little confusing. Yeah.
Well, you got to look at which is your x-axis. D, Leah. Yep. Part E, Courtney. On number 1. Yes. Yes. And then F, Olivia. Sorry, F on the previous page. X or Y? Yes. Because it's Y. It goes through the y-axis. Okay. The ones below. 2A. Vertical line passing through the point 4, -7. Amelia? Yes. And then B, horizontal line passing through that point. Evan? Yep. Part C, parallel to the x-axis. Des? Well, is that the x or the y? Did you say -15? Wait, final answer? What is it? What's your final answer? Oh, okay. So let's talk about this for a second. So for both of these. So here's your x and y axis. Parallel means it would be going parallel, like it would not touch the x-axis, like this green line, right? So does it go through the x-axis or the y-axis? The y-axis. So that means it's a y equals whatever the y value is. So in this case, it'd be 15. Okay. And then for D, this says perpendicular. So it'd be going 90 degrees to the x-axis. So somewhere like that. So that means if it crosses through the x-axis, then it's x equals, whatever the x-coordinate is, x equals 5. Now the next page. Number 3 says, each of the following lines are either horizontal, vertical, or slanted. Label each with its type and then graph on the grid. We will do this part together and then you can do the next part by yourself. So for part 3A, this is slanted because it has a slope. If you want to use coloring utensils for this, you can, just to label them. So the y-intercept is -2, and our slope is 3/5, which means we're going to go up 3 and over 5. Also down 3 and left 5. So there's the first line. This is A. And then for B, y equals 6. Goes through 6 on the y-axis. This is horizontal. So 1, 2, 3, 4, 5, 6. And then you would put a point to the right. Connect them. That would be B. C is slanted. It's going to be slanted down because it has a negative slope. Its y-intercept is 7, and its slope is -1, which means we're going to go down 1, over 1, down 1, over 1. Whenever you go over, you always go over to the right. Because we already went down, which makes it negative, then always over to the right. If you went down and then to the left, that would be double negative, which would make it a positive. So this is C. And part D is vertical line at x equals -4. So 1, 2, 3, -4. Put a point above it, and then connect the dots. And then finally, part E is 2x plus 1. Is slanted. Y-intercept is 1, and the slope is 2. So we're going to go up 2, over 1, as many times, and then down 2, left 1. And that would be E. Do you have any questions? Once you're done graphing those, you do number 4 and 5. So for 4, all 4 of those are 4 separate lines, either vertical or horizontal. So they're not like coordinates to connect. It's not like connect dots. When you're finished, you can check your answers with the neighbor